Friends, let's continue our discussion on carbon accounting. We would be talking about a very interesting concept which is known as CO2 equivalent or carbon dioxide equivalent, and I have named it as the CO2 equivalent as the universal climate currency. Now, what is this? It is basically the CO2 equivalent is a concept which is basically used to convert the different greenhouse gases or used to express the warming potential, global warming potential of different greenhouse gases in terms of carbon dioxide equivalent. This is because different greenhouse gases they have the different warming impacts. CO2, 1 kg of CO2 is not equivalent to 1 kg of methane. In fact, it has been found that if we take a period of 100 years, it is found that methane, for that matter, is 28 times harmful as compared to CO2. So, if that is the case, and if you want to then express the global warming potential of methane in terms of CO2, we would say that 1 kg of methane is equivalent to 28 kgs of carbon dioxide. Similarly, nitrous oxide is found to be 265 times as harmful as carbon dioxide. And we are talking about harmful means we are talking about the global warming potential of that gas over a period of 100 years. So it means that 1 kg of nitrous oxide is equivalent to 265 kgs of carbon dioxide. Same thing about R134A. So 1 kg of R134A is 1430 times that of carbon dioxide. So then what is the CO2 equivalent of 1 kg of methane? We would say that the CO2 equivalent of 1 kg of methane is 28. What is the CO2 equivalent of nitrous oxide? 1 kg of nitrous oxide is equivalent to 265 kgs of CO2 equivalent. So the common currency now is CO2 equivalent, which is used for carbon accounting. So when you do carbon accounting, what we do is that we need to record the daily emissions. And how do we record the daily emissions? By estimating the activity data and emission factor and multiplying the two. So we would be using the activity data like the diesel consumed per day or the oil consumed per day or the coal consumed per day or electricity consumed per day into the corresponding emission factor. If you multiply that two, you will get the daily emissions. And then if that plant is in operation for some 100 days, we will multiply it with 100. If it is operational for some other number of days, so the actual operational days per day into the daily emissions obviously is going to give us the annual emissions, right? So for example, I have taken an example where supposing the daily emissions are found to be 410 kgs of CO2 equivalent, not CO2, CO2 equivalent. And let us say that the operating days are 300 per year. Then the total annual emissions in that year would have been 410 into 300, which is 123 tons of CO2 equivalent per year. So this annualization is essential because most of the reports which we write in carbon accounting like ESG reporting or carbon budgeting, that is basically done on year-to-year basis. So whether the present emissions are less than the previous year, that way we are going to compare the emissions. So it is important for us in carbon accounting to calculate the annual emissions, and all the three, scope 1, scope 2 and scope 3 emissions are calculated in this way.